Hello, hello, welcome back. Our next word problem on the list is proportions. So this is probably work like you've got a good handle on already. Like, to me, it seems more innate, more common sense. One of the big ideas behind proportions is that it has to be applicable to the whole sample. I say this because the way statistics are used in the news, very rarely is the statistic they quote actually applicable to the whole sample. Like a lot of the stats rolling around about COVID are just, yeah. Basically, if you can't see what the person's assumptions were before they came up with the calculation, don't trust it. All right. But in math land, proportions always work. So here in math land, we have a biologist. So to try to estimate the number of bass in a lake, biologist catches and tags 24 bass. Several weeks later, the biologist catches a new sample of 40 bass and finds that 4 are tagged. How many bass are in the lake? Okay. So the catch here is making sure that however you set up your proportion, that your units are consistent. So either they are the same on the top and the same on the bottom, or yeah, same on the top, same on the bottom. Because if you try to do the same ones in one, it doesn't always work. Like you can flip one. So to set that up, we have to be able to talk about and label these. So we have biologist catches and his tags. And then we're trying to compare this to the whole population of fish in the lake. So originally he tags 24 out of however many fish are in the lake. Then later on, assuming the proportion is still true, which in Mathland it is, people, don't go fishing, don't mess with this. In his new sample, he caught 40, and there are 4 tags out of the 40 caught. All right, so we got 24 out of unknown and 4 out of 40 tags versus total fish, and then our small sample here is 4 tags out of 40 fish. So a couple of ways to solve it from here. Some people will look at how do I go from 4 to 40, do the same thing here. Other people will look at how do I go from 4 to 24, do the same thing here. Other people just write it as an equation and solve it. Really isn't a right or a wrong way to do it. If you're following along with my first ideas, you may already know what the answer is. I'm going to go through the equation just because that's what Alex will do. So I'll put an X instead of the question mark. And then to solve this crazy equation using the clearing fractions trick, which is always fun to do, our common denominator is 40 times X. And I don't know what 24 times 40 is, and at the moment I don't care. I am just going to leave it as 40 times 24. And then over here, the 40s would cancel and we just have 4x, because I know the next step is going to be dividing that 4 over. And 4 goes into 40 10 times, or 4 goes into 24 6 times, but I like 10 better. And we end up with 24 times 10, or an estimated fish population of 240 bass in the lake. Now, I'm not sure if that is actually what biologists would do here. Like there's a few more assumptions you'd have to make. It can get a little hinky, but it's probably more about there's an error margin on that 240. But you could probably at least say for sure there's like maybe 160. Yeah, it just depends on the assumptions you make what the error margin becomes. All right, we're going to move on to geometry next in the next video. Stop.